Hi, this is Avril Sauter talking about CCNA Wireless. In this short lesson, we just want to cover the network nodes that are part of a wireless network. And it really sets the scene for understanding those components when we get then into more detail about each of those specific nodes in later lessons. So we're going to literally step through the different physical components that you might expect to see in an enterprise deployment. So we'll start with the client, what is referred to in the 802.11 terminology as the station. Now, client devices increasingly are built in to the actual product. So for instance, it's hard to imagine today buying a laptop or a tablet that doesn't already have Wi-Fi in them. On some tablets you'll see it's just supporting the 2.4 gigahertz band, but increasingly what you're seeing on both tablets and laptops is it will support both the 2.4 and the 5 gigahertz band. So it's got a dual radio in there that will connect on either. What you're also seeing increasingly is Wi-Fi in smartphones as well, and I think the percentage is something like about 95–96% of smartphones now include Wi-Fi. Now quite often when it's in a smartphone, what you'll see is you perhaps won't get some of the highest data rates, or it might just support the 2.4 gigahertz band and maybe it doesn't operate in the 5 gigahertz band. So whenever you're looking at a client, you should always look as to what frequencies is this supporting, what data rates does it support. They're also possible for you to buy adapters so you can add Wi-Fi to a device that's currently not wireless enabled. I recently connected my desktop on a wired connection. I have it wired in my home, but for various test reasons I decided to put a wireless adapter to it. And I bought an adapter much like you see in the middle here. Slightly different in the sense that it had a USB, but it had a longer wire connected to it, so I could actually put the radio up a little bit higher, put the USB into my desktop, which is on the ground, but actually run the cable and the actual antenna up to my desktop, and that's working quite well. Alternatively, you could just use a USB stick like shown in the middle here. I will use something like that if I'm conducting a wireless site survey, simply because the results are more consistent than if I'm using a Wi-Fi that's built into my laptop while I'm doing that site survey. Over on the left here, you can see a PCMCIA card Wi-Fi adapter. And you typically don't see these larger adapters anymore. If you've got a device that's pretty old that you want to connect, then that is one way to go. A few months ago when I got my Cisco Spectrum Expert, that runs on the card bus, and that is pre-PCMCIA, and so I had to get a card bus to mini PCMCIA card adapter, and then I had to find an old laptop where I could plug in a mini PCMCIA card in order to get that wireless adapter to work. It took me about 2 weeks with trying and researching it and ordering equipment to get that product actually up and working. So you typically don't see that, but there are some times when you might have to come across that form factor and use it. Now over on the right here in the picture, this is another Wi-Fi card that you could put into a desktop. The issue with this is that it plugs into the back of the desktop, and your desktop has a lot of metal in it, is also typically on the ground, and so when you use something like that, yeah, it's Wi-Fi, but sometimes you don't always get the best coverage because your equipment is not in the best RF environment, and hence why I chose one that related to the middle so I could actually put my antennas up on the desk. So let's come up a little bit further in the network. So clients in an infrastructure basic service set will communicate with an access point, and the access point is the device that gives me connectivity to the wired network, either my corporate network or the internet. Now there are different types of access points that you can buy. You can get them quite cheap for the home, $20 to $40 I've seen them as cheap as, and perhaps that would just be a single radio, might even be 802.11n, but normally doesn't support the really high data rates. Normally just has a couple of antennas. In a business environment, so at home I run my small business office, and so I want a business grade access point, and so I forked out and spent about $150 and have an access point which has a lot more features and capability on it. In larger settings, such as corporate environments, then you want to go to a higher quality one, and some of those can be somewhere between $600 and up, depending again on the features and capabilities on it. Some of the high-end Cisco products can be almost close to $1,000, but they provide advanced features like the ability to sniff the air and detect interference, look for rogue access points, etc. So again, depending on the features that you want on your access point, you will pay more. But in a business setting, you really want to take a more advanced access point because you want it to be able to operate perhaps in a lightweight mode versus an autonomous mode, and we're going to talk more about the differences of modes of operation a little bit later on. The other type of access point, of course, is an outdoor access point. And so here in this picture is a business grade access point from Cisco. It's got internal antennas and is not housed in an environment that could be placed outside. And so this is an internal access point. If you were deploying outside, then you would want a housing that is robust and can protect you against things like rain and fog, etc. And so you can get external access points which are appropriately housed. This access point also has internal antennas, and this works well if I'm deploying it in a wide area where I don't really have a very difficult RF environment. I'm not trying to do corners and wall coverage, etc. There are some environments, let's say I'm trying to get coverage in a corner, that I might say, okay, well, let me use external antennas so I can get more gain on my antenna in specific directions. And so then you'd buy an access point with external antennas. There are lots of manufacturers of access points. Access points, you always want to look to make sure they're Wi-Fi Alliance certified so that you can make sure that your client and your access points can communicate. In my lab, I have a couple of access points which I got shipped to me from Germany which aren't certified, and the reason they're not certified is I wanted to get in and particularly tweak a few factors and features which you can't always do on a certified product. And so in a lab environment it's not so bad to do that, but in a commercial environment you really want to make sure those are Wi-Fi Alliance certified. So your access points will connect to a wireless LAN controller if they're operating in a lightweight mode. And I mentioned that earlier. Lightweight really means is that the central processing is done on the controller. So things like the configuration and the management of those access points done centrally on the controller, and then those configurations are pushed down to the access point as opposed to being individually programmed. And in that environment you must have a wireless LAN controller, and here you can see a picture of one from Cisco. These wireless LAN controllers come in different formats. You can get the smaller one, which is really small and cute and can just sit in a secure IT area. Other times people will put them into an equipment closet, might put them into a rack and some sort of enclosure. Now you can run your wireless LAN controller as a separate appliance, or you can actually run it as a software which then you install on another device. So some flexibility there in terms of where and how this is deployed, but still you need the capability of doing some form of central control. And typically I find personally, if you get above 6 or 10 access points and you have a changing environment, you're better off going to a wireless LAN controller environment and centrally managing your access points. Now I'm going to talk about the bottom of this slide first, the access point power options. So access points, when you deploy them, you can either power them where they're deployed, but what is more common is that you'll run power over Ethernet, which enables you to run one cable from your switch through to your access point. If the distance is over 100 meters, then you'll need to use a power injector in order to go the greater distance. So you'll need to do a power injector onto that Ethernet cable. So if you're going to use power over Ethernet from your switch, then you need to make sure your switch supports power over Ethernet. If it doesn't, then you might have to look at replacing switches as part of your wireless LAN deployment. Typically an access point will connect into a switch, and that might be a layer 2 or a layer 3 switch. Now in a large enterprise environment you'll see the access points going into switches rather than routers, but in a small office environment, especially if you just have 1 or 2 wireless LANs, I have seen the wireless LANs going directly into the router itself, and it kind of gives you an all-in-one kind of capability in terms of deploying your access points, and it can save some costs for that site. So just be aware that sometimes you can put those wireless LAN controllers into those rather than switches. And of course you can also, in a small environment, could put your wireless LANs directly into your wireless LAN controller. But typically what you want to do is have multiple wireless LANs connecting through switches and then into the wireless LAN controller. So to wrap up this lesson, a couple of key terms. The first is the wireless access point. This is a network node that allows your wireless devices like laptops, smartphones, tablets to connect to the wired network. And then the wireless LAN controller. This is a device that helps you manage your access points, and so it pulls back all that intelligence into a central location, allowing your access points really just to handle the radio aspects, which is why it's called lightweight access points, and we'll talk more about that wireless LAN controller as the course goes on. Thank you for listening.